Welcome back to the lab, folks. Today my channel surpassed 5,000 subscribers. That's just phenomenal. I never thought it would get that far. Anyway, thank you very much, folks, for being a part of this. And in order to kind of commemorate that, I decided I'd do a little video today answering a couple of questions that I got. So one question was regarding this little Zoe oscilloscope. Somebody had been using it to measure the output of a wall wart like this. Now this is a AC to AC wall wart, so it's just got a transformer in it. There's no switch mode power supply in it. There's no rectification or filtering or anything else. And he had something similar to that. And he was wondering why he wasn't seeing what he was supposed to see when he connected up the oscilloscope, which he thought he would see what was on the specifications on it. However, I think what he didn't understand was that these specifications are rated load. So at this one here, it says 13.2 volts AC at 830 milliamps. These things have quite a bit of internal resistance. Some are better than others. This one's not too bad. It's got a fairly low internal resistance. I think I measured it around about 1.5 ohms or something like that on the secondary. Not only the secondary load's down, but also the primary load's down, and this brings the voltage down to the specified value. But if you don't have a load on it, they can be quite high. So let's have a look at that. I've got this AC load over here. I just disconnected it here so I can show you what the no load voltage is like. And I'm running that through the meter, and I've got an oscilloscope, this one, across it, so we can have a look at the waveform. And I've got the frequency, peak to peak measurement, and RMS values showing here. So let's turn on the power. Now we can see that without the load at all on it, we're getting 44.3 volts peak to peak and RMS value of 16 volts. So that's nothing like 13.2 volts, is it? So let's start putting a load on it and see what happens. Let's connect up now. Right now I think this is going to have 280 milliamps going through it. And already it's dropped the RMS voltage by an entire volt. And the peak to peak voltage has come down tremendously too. Now let's put this up to the rated value of 830 milliamps. So I've got 840 milliamps there. That's close enough. And we see now we're down to our RMS value of 3.5 volts, which is pretty close to the specification. And the peak to peak voltage is dropped down to 37.6 volts. That's it. That's the reason why when you take these little transformer type wall warts and you measure them open circuit, you're going to measure much higher voltage than what. So there was nothing wrong with your little oscilloscope. It's fine. It's doing exactly what it's supposed to do and telling you the truth. Just to show you what's inside one of these things, I'm going to cut this sucker open and I'll come right back and we'll have a look at it. All right, here we are. So I just cut that off with a Dremel and there's a little transformer inside. Now I find these are a great source for little transformers. So I collect these whenever I can. You go to swap meets, garage sales and stuff like that, you'll see these little wall warts out there. And I always pick off the little linear ones, the little transformer ones, because they are a great source of transformers. You can get them really cheap. I've never paid more than 50 cents for one of these things. Yet you've got inside a transformer that costs you $5 or $6 minimum. And I'm going to use this, actually. I've got a good use for this particular transformer here, because it's just in the right voltage range for what I want to do with it. So watch for a video coming up doing that. And that's it. So that's what happens here. These little transformers here, they need to work at their rated load in order to produce the rated output. Okay, that's it. That's the answer. All right, let me set up for the other question and I'll be right back. Okay, my next answer is going to require me getting an oscilloscope up here on the screen. All right, so the viewer asked me if I was going to consider doing a modification on this to increase the capacitance measuring for ESR from 10 kilohertz to 100 kilohertz. Unfortunately, I'm not, and the reason is that these do not work that way. A normal LCR meter like this, I wouldn't call it normal, but even this little mini Fernisi one here, what it'll do, it'll put a frequency through. You can see it up there on the scope. So these ones do actually have a sine wave output, and you can vary the frequency like that. Now this one's only got 3 different frequencies. My East Tester ET4410 has got hundreds of different frequencies. Yeah, these ones work a little bit differently though. So let me hook it up to this device over here. is probably going to pick up all sorts of noise from the lab. Yeah, we got a 60 cycle hum coming in there. So try to ignore that. There's not much I can do to get rid of it. I'll put this on single and then we'll turn it on. Have a look at this. So let's move this out of the way here, then we'll expand this out. So you can see what it does is it sends out a series of pulses. Now these are the little oscillations in between the pulses. That's just the noise that's picking up in the background. And basically these are trying to figure out what's attached to it, right? So it's putting out negative voltages and positive voltages, and could be a diode, a transistor, whatever. And it's just trying to determine what's attached to it, if anything. So let's put a capacitor on it. This one here is a 10 microfarad capacitor. And I might show you a couple other ones too, because it uses different approaches for different size capacitors. Single shot. Okay, so now the pulses look a little different, right? But they're still the same pulses. So you see those first pulses there? They're the preamble, trying to decide what kind of thing it is they're testing here. Up here, and then it's finally figured out, I think around about here, it's figured out it's a capacitor, and it's a capacitor of a certain size. So then let's have a look here at this ramp here. This ramp is it measuring the capacitor. So what it's doing in this case here is it's pulsing. It's putting little pulses of voltage across it until it gets to a certain level. And once it reaches that level, it says, okay, what's the time it took us to get there? And it calculates the capacitance for that. And it does some other tricky things, like shortly after that to determine the ESR. So, but they're not terribly accurate because they have to go through this. They don't have that proper method that this little thing uses. Usually the ESR readings on these are not that great. Now let's try a different capacitor. It'll use a different strategy. Let's see if it does with this. This is a 1 microfarad capacitor here. Let's try to get this centered a little bit. Let me bring up the cursors here. So as you can see that it's using a frequency of around about 758 hertz. So it's nowhere near 10 kilohertz or 100 kilohertz. That there is for the ESR measurement, and then that over here, this rise time here is for the capacitance. You can even try a bigger capacitor. This one here is a 680 microfarad. All right, now we've got a completely different pattern again. So after the initial preamble there, you can see that this one here is a completely different strategy again. And to be quite honest with you, I don't know where it is determining the capacitance in this or the ESR. I can only assume this is the capacitance measurements here, and this here might be the ESR. I'm not sure. But you can see that it doesn't do the same thing every time. It does not necessarily use any frequencies at all. And the frequencies it does use are nowhere near 10 kilohertz, let alone 100 kilohertz. All right, that's it, folks. Again, thank you very much for getting me past 5,000 subscribers and for getting me over 500,000 views. That's phenomenal. This seems to be a thing. So I might set up a Patreon if anybody's interested in supporting the channel. I'll let you all know about that in the next little while once I get it set up and put out there. Thanks for coming out. I hope the guys who asked the questions got something out of this, and I'll see you all next video.